What you're watching right now is a scaled-down cable catch test, a pretty unique approach China is exploring to recover and reuse rockets. And here's the interesting part. This isn't just an early concept anymore. China has already built a much larger, full-scale system designed to catch a real rocket booster mid-air, potentially for use with its next-generation lunar launch vehicles. So what exactly is this system? How does it actually work? And more importantly, is it better than the way SpaceX plans to catch its rockets out of the sky? Let's find out. Spaceflight has always been a tough game. Brutal physics wrapped in some seriously elegant engineering. Every kilogram counts. Every bolt matters. Add just a little extra weight to a rocket, and that's weight you're not sending into orbit. That's exactly why reusable rockets are such a big deal. If you can bring the booster back and fly it again, the cost of getting to space starts dropping fast. Now, China is testing a pretty unusual way of doing that. Off the coast, there's a massive 144-meter ship called Linghangzhe, roughly meaning the Navigator, or the Pioneer. And its job sounds almost crazy at first, catching a falling rocket booster out of the sky using cables and nets. If it actually works, it could become one of the strangest and most interesting recovery systems ever built. This ship wasn't thrown together quickly either. It's a full-scale ocean platform, about 144 meters long, 50 meters wide, with a draft of around 5.5 meters and weighing roughly 27,500 tons. Built by the China Academy of Launch Vehicle Technology under CASC, it officially entered service in late 2025. If you love to see SpaceX catching its giant rocket, you probably already know that catching a rocket mid-air isn't something you can just try and see what happens. When a booster comes back down, it's still moving fast, and even small changes in wind or atmosphere can shift its landing point by hundreds of feet. To deal with that, the ship uses a DP2 dynamic positioning system. Basically a set of computer-controlled thrusters that keep it locked in place without anchors. Even in the open ocean, it can hold position with near meter-level accuracy. Imagine a 27,500-ton ship just hovering in place. On deck is where things get really interesting. The ship carries a giant capture system, an array of tensioned cables, hooks, and structures stretched across an area roughly 40 by 60 meters. As the rocket stage descends, it aims for this zone, and the cables absorb its remaining energy, kind of like a massive safety net catching an acrobat. Traditional vertical landings, like the ones used elsewhere, require rockets to carry extra gear. Landing legs, stronger structures, extra fuel, hydraulic systems. All of that adds weight, and in rocketry, weight is the enemy. With this approach, most of that complexity moves off the rocket and onto the ship instead. The booster can stay lighter, which means more payload capacity and better efficiency over time. In this setup, the ship does the hard work. The rocket just focuses on flying. The system is being developed alongside China's next-generation Long March 10 rocket, which is aimed at future lunar missions. On paper, the process goes like this: launch, stage separation, controlled descent, the ship locks into position, and the booster drops into the capture system. Simple in theory, very not simple in reality. The idea of net-based recovery has actually been around in China for a long time. Around October or November 2024, during Starship's fifth launch, SpaceX achieved first-stage recovery using chopsticks. Following that, China then announced that it could use a net-like system for recovery. Construction reportedly started in April 2025 and wrapped up by December. Just 7 months for a vessel of this size and complexity. By early 2026, it was already out at sea for testing, with engineers still adding and refining the capture system. It almost feels like watching a regular ship get turned into a giant rocket-catching machine in real time. The latest test that ties into this whole system happened on February 11th. A Long March 10A test booster, with the Mengzhou capsule mounted on top, lifted off from Launch Complex 301 at the Wenchang Space Launch Site. After separating from the spacecraft, the booster kept climbing, reaching an altitude of about 105 kilometers, just over the Kármán line, the edge of space. Now, this flight didn't involve an actual mid-air catch with nets, But what did happen is still pretty important. As the booster came back down, it maintained a stable vertical orientation and performed a controlled splashdown in the ocean, landing very close to the Ling Hangzhe recovery ship with impressive accuracy. It shows that the rocket can precisely target a recovery zone at sea, which is absolutely critical if you ever want to catch it with cables. At the same time, it also demonstrates that the ship can position itself correctly and operate in sync with the incoming booster. So while no net was used this time, the test essentially checked two key boxes: guidance on the rocket side and positioning on the ship side. So yeah, China does have a very unique way of recovering rockets, but I know a lot of people are wondering, is it actually better than how SpaceX does it? Because when it comes to rocket recovery, especially the first stage, most people immediately think of SpaceX. Ever since the first successful Falcon 9 launch back in 2010, Elon Musk has been talking about recovering and reusing rockets. At the time, a lot of people thought it was kind of a joke. Even inside the industry, plenty of folks didn't think it was really possible. But then, they actually did it. And not only did they pull it off, but they also proved just how effective it could be. Now, reusable rockets aren't just an idea, they've basically become the way forward for the entire space industry. Once SpaceX successfully mastered first-stage recovery using landing legs and found they could control the flight attitude accurately, they proposed using chopsticks to recover the first stage. This was seen during Starship's fifth flight in October 2024. The video of the first stage being caught by the, quote, chopsticks at the launch pad shocked the world. Since then, the first stage has been successfully recovered several more times, and Musk is even preparing to test the reuse of the first stage. So, Musk's rocket recovery system, that tower about 145 meters tall, is essentially a giant steel frame with rails and moving chopstick arms. These arms are powered by electric motors pulling steel cables through a pulley system, adapted from oil rig technology, allowing them to move up and down the tower. Hydraulic pistons control the opening and closing of the arms, which are massive truss structures built to handle extreme loads. The rocket booster has small catch pins, and the arms have matching catch rails. As the booster descends, it constantly sends its position to the tower via radio. The tower adjusts the arms in real time, while radar sensors fine-tune the alignment in the final moments. As everything settles, the pins align with the rails, and the system transitions into a controlled catch. At engine shutdown, the rocket's full weight transfers onto the arms. Shock absorbers and hydraulic systems then lower it slightly, about 1 meter, to smoothly absorb the remaining momentum and bring it to a stop. So, in a way, nothing here really relies on some magical new invention. It's mostly existing tech, cables, hydraulics, sensors, just combined in a new way. Now, let's compare China's net recovery system with SpaceX's chopstick tower. At the end of the day, the whole point of reusable rockets is simple: make recovery and reuse as cheap and fast as possible. If you go with landing legs, the process is pretty involved. After landing, you have to hoist the booster, remove the legs, lay it down onto a transporter, and send it back to the factory for inspection. Then it's the whole process in reverse. Reinstall the legs, attach the second stage, add the payload and fairing, and roll it back out to the launch pad. It works, but it takes time. Chopstick recovery cuts a lot of that out. Since the rocket is caught and stays vertical, you can basically place it straight back onto the launch mount. If guidance and control are solid, it starts to feel more like an airplane. Land, do a quick check, and you're almost ready to go again. In a fully mature setup, it gets even faster. The tower catches the booster, sets it down on the pad, then lifts a waiting second stage and stacks it right away. In theory, you could turn things around incredibly quickly. Now compare that to net recovery. The net is usually positioned far from the launch pad, so even after a successful catch, you still need to extract the rocket, transport it back for processing, and then bring it out again for launch. That adds a lot of extra steps, which means more time. So, from an efficiency standpoint, net recovery does seem slower than the chopstick approach. There are also some technical challenges. With a rope or net system, everything has to be perfectly synchronized with the rocket. You need a real-time data link so the system can track the rocket's attitude precisely during descent. And don't forget, the engines are still firing during landing. That means you have to deal with extremely hot exhaust that could damage or burn the ropes. If the net or cables need to be replaced after every catch, that adds cost and slows down reuse. That said, this is all early-stage tech, and it can definitely improve over time. Right now, net recovery doesn't really have a clear performance advantage over chopsticks. But it does have one interesting upside. It puts fewer demands on the rocket's attitude control, which might make it easier to achieve in the near term. It's also done out at sea instead of right on the launch pad. So if something goes wrong, you're not risking your entire launch infrastructure, just the rocket and the recovery system. Okay, so we've come to the final question. Can China achieve something like SpaceX's chopstick catch system? Short answer, yes, they can. But it's not going to be easy. The key thing to understand is that SpaceX didn't jump straight to chopsticks. They built up to it. First, they mastered landing with legs on the Falcon 9, gaining years of experience in precise attitude control and engine throttling. Only after hundreds of landings did they seriously move toward catching boosters with the Mechazilla. That system demands an extremely high level of precision. There's almost no margin for error, and SpaceX got there through constant testing, high flight cadence, and yes, a willingness to let prototypes fail to gather data. China is taking a similar path, just at an earlier stage. Since around 2018, when the government opened up the commercial space sector, a wave of private companies has emerged. Firms like iSpace and Galactic Energy initially focused on reaching orbit, often with solid rockets, to attract funding. But at the same time, they've been developing reusable Falcon 9-style liquid rockets. These are typically two-stage vehicles where only the first stage is recovered, usually via landing legs on land or a drone ship. Rockets like Juche 3 and Long March 12 have already begun testing this. The results aren't perfect yet, but the progress is fast. For example, Juche 3 managed a successful re-entry burn and came down very close to its target, within a few tens of meters. For a first attempt, that's actually impressive. So right now, China is still building that foundation, learning how to control the rocket precisely during descent. At the end of the day, this is all part of a much bigger push toward fully reusable rockets, a goal every major space program is racing toward. If you can recover and reuse the most expensive parts, you dramatically lower the cost of getting to space. Whether it's a cable-catching system at sea or a towering structure designed to grab a booster out of midair, these ideas may look very different, but they're chasing the same end game. And if a rocket booster really does get snagged midair by a ship in the ocean one day, that's going to be one of those moments that makes everyone pause and think, all right, we've entered a new era.